Okay, so I'm going to graph for you basic cosine graph here. What we have here is an example, 3 cosine 2, x minus 90 minus 4. So what you need to do is find the basic function for any of the sine, cosine, or any of the trig graphs. It looks like this, where the A represents the amplitude, that's out in front. The B is your period constant. I'll explain that in a minute. That's here in front of the parentheses. The C is your phase shift. That's inside the parentheses here. And D is your vertical shift. So you should be able to relate this to things that you've done before in Algebra 2, like here is an example of a quadratic function. How do you know it's quadratic? Because you have an x squared there. So whenever you have this inside the parentheses, if you'll recall, that is your shift left or right. In this case, it will be right by 2. This over here on the side was your vertical shift, just like over here. The D is your vertical shift up or down. And this number 3 in front did a stretch or a compression. Okay, so the amplitude is similar to that. It will make your graph either higher or lower. So here's what we're going to do. We're going to write down each of our numbers here. So we have the A equals 3, right? The B equals 2. The C equals 90, right? X minus C. This is the C right here. Okay. And the D is equal to -4. So remember, A is the amplitude. B is the period constant. So I'll explain that in a second. It is not the period, it is the period constant. C is the phase shift. And D is the vertical shift, up or down. Okay. So the first thing you're going to do, I'm going to move this up a little bit. We're going to write the midline. This right here, this line right here is the midline. And D is the midline. The line in the middle line, okay? D represents the midline. In this case, what do you have for D? -4. So I'm gonna, let's see if I can do that in there, -4. Okay, next thing that I'm going to do is I'm gonna do the amplitude. So the amplitude is half the distance of the entire wave between the max, this is the max line, this is the min line, this is the middle. Okay, so A is half from the middle or half going down below here. This is also A over here. So let me see, let me get rid of that. So I'm going to rewrite that. -4 is the midline. And then your A is equal to 3. So it's 3 up from 4 or 3 down from 4. So up 3 or down 3. So if you went here, I'll write it again, -4. Sorry, can't see that very well there. I'm trying to get a good color here, white, -4. Okay, so up 3 is the amplitude. So if you start in the middle at -4, you go up 3, that's -1. If you go down 3, that's -7. So your maximum height will be -1. Your minimum height will be -7. Okay, so D is the middle. And then you go up and down by 3 from there. All right, the next thing that I want to do is graph the cosine. You have a cosine wave, that's what it tells you, it's a cosine function. So quadrant 1 of a cosine, it starts at a max and it goes to 0. Quadrant 2 of a cosine, it starts at 0 and it goes to minimum. Quadrant 3 on a cosine wave starts at a minimum and goes to 0, or the middle line. And then quadrant 4 on a cosine starts at the midline and goes to the back up to the max. So you have your 4 quadrants of a circle represented there, stretched out over time. Now this way, going this way, that's representing your angle as you go along here. Okay, so now we have your phase shift, which is this here, the C. That represents, let me write it down, C is your start phase shift. So you've moved the whole cosine wave left or right, this direction, okay? That's your phase shift. So in our case, we're starting at 90, we're talking about here, 90 degrees, moving this way, okay? Okay, so now you've got to do, the last part is the period, which we're going to call E, is the period. Okay, so E is represented by 360 over B. Okay, so that's why we're calling this the period constant. It is a number, a constant that you use to determine the period. Okay, so in our case, we have 360 over 2, okay, which equals 180. That means our whole period from the beginning cycle of the cycle to the next part where the wave starts all over again, this one cycle of the wave, the whole wave, is 180 degrees long. No matter where you put it, left or right, one cycle of this wave from peak to peak is 180 degrees long. All right, so now what you have to do is break that up into the 4 quadrants. Okay, so 180, the total of 180 in 4 pieces. So 180 divided by 4 will equal 45, correct? 45 degrees. Okay, so that means each of these quadrants here, you are adding 45 to the start. You started at 90, it's like a bank balance, right? You start at $90 and you're adding 45 each time. 45 added 4 times together would equal 180. So what's 90 plus 180? That should be your end point over here, okay? $90 plus $180 would give you your end over here, okay? So we're just going to add $45 at a time, or 45 degrees. I'm using dollars because it seems to help students understand the idea behind it. So 90 is your start phase shift, and then you add another 45 degrees to that. What is that? Make sure I'm doing it right. Calculator. So 90 plus 45, 135. 135 here. Okay, plus another 45 gives you 180. That's just a coincidence there, okay? Plus another 45 equals 225. Here, plus another 45 gives you 270. Right? So 90 plus the entire thing of 180, 45 plus 45 plus 45 plus 45. That equals 180 there. 90 plus 180 should equal 270. 90 plus 180 equals 270. Yes, I was just checking that out. Okay. And there is your graph. You just graphed a cosine function. So again, we started with the midline. D represents the middle line. Then you go up and down by 3. That's the amplitude. Up 3, down 3. And then we drew in the cosine wave. The cosine always starts at a max, goes to the midline, goes to the min, back up to the midline, and then back to the max again. That's always your basic cosine graph. Then we determined where this wave was shifted left or right by the C. Okay, so C started at 90. And then you wanted to know how long was this entire wave. That's determined by the period right here. Period is determined by 360 divided by your period constant, which was 2. So 360 divided by 2 was 180. So your whole wave was 180 long. That's divided up by the 4 quadrants, or the increments of the wave. 180, it just happened to be 180 long. It could have been a different number. Okay, so 180 divided by 4. You add that to your starting point, which was 90 plus 45 plus 45 plus 45 plus 45. Okay, so that's your entire wave there. Let's try one more example. I'll do it in radians this time. Let's try something similar. Let's do 2 sine. Let's do again 2, and then x plus pi. I'm using radians now. And then let's whatever, plus 5. Okay. Here we can use a different number up here if that'll make you feel better. Let's use 4. Okay, like that. So what you have here, remember A, B, C, D. Okay, so I want you to recognize that. X minus C, I hope that's raising a little flag for you there, plus D. Okay. What you should be seeing there, how do you make a minus a plus? How about this? X minus pi. Would that give you x plus pi? Okay, so that's how you look at it. So this is your C, x minus C. Okay, so let's write down the ABCs here of this one. The amplitude would equal 4. The period constant would equal 2. The phase shift would be minus pi because it's x minus the phase shift. So the way you get the plus is a minus there, okay? So that would be negative pi. And then your vertical shift would be plus 5. That's your D, okay? So that's the amplitude, period constant. This is the phase shift. And this is a vertical shift. Okay, so this is your midline right here. So let's see if we can draw a nice 3 lines here. So midline. So the midline is D right here. So we're going to put on there 5. And then it's going to go up and down by 4. So 5 plus 4 is 9. And then this is 4 there too. And then 5 minus 4 is 1. So our maximum height on this wave would be 9. The minimum height would be 1. Next thing I'm going to do is to draw a sine wave. Okay, so let's draw that sine wave in there. So a sine wave always starts at the midline, goes to a max, then that's quadrant 1. Then it goes from the max to the midline, quadrant 2. Quadrant 3, it goes from the middle down to the min. And then quadrant 4 goes from the min back up to the midline there. So we have 1 quadrant, 2 quadrants, 3 quadrants. Do you see the pieces of the circle? I hope you're seeing the pieces of the circle. Okay. All right. Now we can do the phase shift. which is this left and right direction. So the whole entire wave is starting at negative pi. Okay. So you have a period, which is E. Period, which is the same, 360 is the same as 2 pi over b, or 360 over b. Okay, we're using radians now, so we're going to stick with radians. So it would be 2 pi over 2. B is 2. Okay, I'm just substituting in for b. So 2 pi divided by 2 would equal pi. That means, so it's hard for people to think in the terms like this, but that is the length of your whole wave right here. From here to here, the length of the entire wave is pi. So if you're starting at negative pi and you add pi to it, you're going to end up at a 0. Should be, okay? Starting at negative pi, you're adding a whole pi to it, you end up with 0. But we need to find these in-between incremental points here. So we have our starting point is at pi. What is our maximum at? This, our midline here, our minimum, and then our endpoint is at 0. Okay, these are called the critical points. Okay, so the way you get this is you divide that pi into, right, your whole period, divide by 4. So each one is going to be pi over 4, each of these increments. Pi over 4, pi over 4, pi over 4. So negative pi plus pi over 4 would give you, right? 4 pi over 4 is the same as pi over pi, right? So negative pi plus a quarter of a pi gives you negative 3/4 of a pi, plus another quarter of a pi, right? You're adding all those increments up. That would be half a pi. Okay. That's just, that blue one is determining the whole length of the whole thing. Negative, sorry, right? Plus another quarter of the pi would be down a quarter, right? Negative $1, negative 75 cents, negative 50, negative 25 cents, 0. Okay, trying to help you see the fractions there. Okay, so people don't like radians because it involves fractions and it's a lot more abstract. That's why I do the degrees. So we need to practice these in class. So I hope that helps you out there. That's all you have to do. You've got the midline again is D, up and down by the amplitude. Then you draw in your wave. Sine wave starts at the midline, ends up like this. A cosine would start at the max and end with a max, just like we did above. Then you write your phase shift. Where does the wave start? Determine the entire period. How long is the wave? Divide that up by 4, and then add that to the starting point. Starts at negative pi, add up those 4 increments to it, and then you get the end of your wave. Okay, so thank you very much.